Hello and welcome back to What's What. Today we are going to talk about wildfires. A reality in today's world. They can be caused by a variety of factors, both human and natural. We will examine how they are ignited by transmission lines. But before we get started, don't forget to like and subscribe below. Combustion, or burning, is a chemical reaction between fuel and an oxidant. It produces smoke, heat, and light. And when a substance vaporizes, the reaction becomes a visible flame. But a reaction between fuel and oxidant is initiated only after activated energy is presented. The heat from the flame then provides enough energy to make the reaction self-sustaining. When we think of flames, the first objects that comes to mind may be a match or lighter. With that in mind, we know the energy to ignite a fire does not need to be grand in size. When you add other elements, fire size can grow. Let's take a look at wildfires and how to mitigate them. A wildfire typically occurs in an area of combustible vegetation. The severity depends on the available quantity and nature of the fuel and weather conditions. So although wildfires occur in dry conditions, the weather cycle does play a role. We typically see wildfires in climates that have wet periods followed by spells of heat and drought. Wind also plays a factor and can push fire propagation across huge areas. Studies show that climate change has increased the occurrence of wildfires. Sadly, it looks like they will be a recurrent danger in the future. If we consider natural conditions, moist vegetation typically prevents ignition and slows propagation. But high temperatures can evaporate the water contained in plants or trees, and flames will eventually overwhelm their moisture. In a basic sense, wildfires come down to three factors: oxygen, heat, and fuel. When we look at causes of fire or ignition, natural phenomena like lightning, volcanic eruptions, and bacterial fermentation are most typical. But ignition can also be caused by human activity. An overhead transmission line pushes electric current through a bare conductor. Air is their insulation and naturally withstands the voltage levels they transfer. That is why overhead transmission lines are situated high above the ground. On such lines, there is no coating or protective layer around the conductor. Say there is contact between the energized conductor and the ground. In the case of a toppled line, for example, the overhead conductor can act as an igniter in drier climates. As mentioned, the falling of an overhead transmission line is a typical cause of wildfire. There are several factors that can cause these suspended conductors to fall, such as poor maintenance or severe storms. Ideally, the power distribution system will detect any fault the same way your fuse or circuit breaker does at your home. Power line systems have a device that detects any short-circuit situation and clears any fault to limit possible damage. On the other hand, the system settings cannot be so sensitive that they falsely trip and cut power. When the overhead conductor has fallen, the electrical resistance of the ground surface can be relatively high, and the current may be low enough that it is unable to blow a fuse or trip a circuit in the line. This is known as high impedance fault. In drier conditions, the conductor, still active, will ignite vegetation in the vicinity. Toppled lines are not the only cause of wildfires. Overhead lines are often the most cost-effective technique to transfer electricity across large areas of nature. although routes are selected to limit impact on the environment, contact between vegetation and the lines can still occur. Sometimes vegetation, such as a tree, can fall and make contact with a transmission line, causing fire. So, these corridors of transmission must be maintained to avoid contact. This is made possible by regular pruning and cleaning the area below the lines. Vegetation management is key and can also improve the habitat for surrounding wildlife. Now, transmission routes are often built in parallel with several conductors that have sufficient clearance between one another. This design is employed for safety, but strong winds or ice can cause the lines to slap together. This occurrence is known as a conductor slap, and the high energy creates arcing that ejects hot metal particles capable of igniting the material below the line. The typical overhead lines are designed for a 60-year lifespan, but they can sometimes be operated for longer periods of time. Insufficient maintenance or severe weather can cause failures. Arcs and sparks are both potential sources of ignition. Sparking faults, as they are known, are difficult to detect and can gain in intensity until they reach plantation, which we know act as fuel for fire ignition. Wildfires caused by transmission lines can spread quickly if located in remote and windy areas. Increasing drought has led to a record-breaking number of recent wildfires. Although these fires begin in remote areas, if not contained, they can travel to domestic areas and threaten homes, animal life, and our safety. When utility companies fail to maintain their infrastructure, they are held liable for the damage. This includes steep fines and lawsuits, not to mention firefighting expenses that can reach hundreds of millions in cost. In the United States and Europe, many transmission lines are at the end of their 60-year lifespan, and many companies are in process of refurbishing or replacing the outdated poles that hold their lines. To prevent transmission lines from causing wildfire, pre-planned outages can be staged to steer clear of risk. This can cause inconvenience for consumers, but may be necessary to avoid destructive events. Routine visits can also stop catastrophe, and today, inspection is achieved by helicopters, drones, and specific airships that checks the routes of transmission lines and detect unusual situations with film and live photos. Audits and refurbishment are of course necessary. Clearance between vegetation and lines must be constantly maintained. And of late, we have seen the increasing shift to underground lines at a competitive cost, which is a much safer option in regards to wildfire prevention. Utility companies will face many challenging investment decisions over the next few decades, with safety, grid reinforcement, and cutting losses playing huge factors in their decision-making. Ignition occurs with the combustion of heat, oxygen, and fuel. Down lines, vegetation contact, conductor slaps, and equipment failure can lead to wildfire. Consequences can vary depending on the size and location of the wildfire. Wildfires can be prevented by maintenance and monitoring. New methods are being developed to prevent wildfire, such as the industrial shift to underground lines. There we have it. Wildfires are detrimental to the environment that we are a part of. To prevent them, we must first understand them and their causes. Do you have any ideas? Feel free to leave us a comment below. This is Frédéric, tuning out.